So here we go, the power rule. Now, in the previous video, I showed you the quotient rule, and the one before that, I showed you the product rule. Those rules use only one specific, specific method, which was adding the exponent if it was a product problem, and subtracting the exponent if it was a quotient problem. The power rule is much different because you will have problems that you will need to apply different methods of the power rule. Let me show you what those methods look like. I applied different colors to each method so not to confuse you. So what I will do is create some problems that will utilize each one of these methods of the power rule. So we have 8 to the fourth raised to the third power. Now look at the black box over there on the right and look at the first method, which is number 1. I tell you what, let's go ahead and label these variables with the value of the problem that we actually have. So we'll say that x is equal to 8, and we say that m is equal to 4, and n is equal to 3. So let's rewrite this just how as it appears in the black box and for method number 1. So we say 8 to the 4th to the 3rd, which equals 8 to the 4 times 3. In other words, this will come out to 8 to the 12th. So we have 8 to the 4th times 3, and 4 times 3 is 12. So now our problem is 8 to the 12th power. And 8 to the 12th power evaluated is 6.9 times 10 to the 10th power. So what I just said was I just gave you an answer in scientific notation. I will go over that with you in a little bit. But right now, I will create another problem that is similar to the second method. So we have 5b to the 4th power. This matches the second power rule method, which is number 2. So we'll say x equals 5. As a matter of fact, let's do this in a different color. We'll say x is equal 5. I put it right over here. X equals 5. Y equals b, and n equals 4. Okay. So let's go ahead and rewrite it and put everything in as it should look. 5b to the 4, which equals 5 to the 4 times b to the 4. Okay. So we can evaluate 5 to the 4th even further. because 5 to the fourth gives you 625. 625. We can't do nothing with b to the fourth, so we're going to leave that like that. If you're still wondering where I get that 625, well, don't forget now, 5 to the fourth is basically 5 multiplied 4 times. Like 5 times 5 times 5 times 5. That's what gave us our 625. Okay. Yeah, so the third method in reference to the exponent rule is a division problem being raised to a power. So right here, the third method. So so if we have a problem like this here, 4 divided by 3 being raised to the fourth power, right? 4 divided by 3 being raised to the fourth power. Now, as you can see from the rule over here, as a matter of fact, let's go ahead and label everything. Let's go ahead and label just like how we see it in the rule. Exactly how we see it. Let's do it in a different color. So we'll say that x is equal to 4, x is equal to 4, y is equal to 3, y is equal to 3, and n is equal to 4. Okay? So let's do this. Point right here. That's that. Y right there. N right here. Okay? I know it look a little cluttery, so I was just going to rewrite it. That's, as a matter of fact, let's just go ahead and rewrite that answer out as it should look right here. Let's go ahead and fill in the blanks. So x, the quotient rule states that 4 is raised to the fourth power and 3 is also raised to the fourth power, which give us a new answer. 4 to the fourth will give us 256, and 3 to the fourth will give us 81. Can it be reduced? I don't think it can be reduced, but I'm just going to leave it like this here. We're not talking about reducing problems anyway, so if you need help with that, then you can do that on your own. But this is what we get. We get 250, we get 256 over 81. Oh, and by the way, make sure that you don't divide by 0. You see where it says y is not equal to 0? So what that means is if you go back up here, what that means is 4, we cannot do this. We cannot divide 4 into 0. We can't do that. That's a no-no. Okay? Let me break it down in a more simpler term, because I know some people might have a problem just with what I'm trying to say. So we can't do this. This is the same problem, the original problem, but I'm just writing it. We cannot, because of that 0, we cannot divide by 0. That is undefined. That is undefined. Okay. So I mentioned a problem that I wrote down. Well, I actually didn't wrote it down. I was supposed to write it down. I only stated it, which was 6.9 times 10 to the 10th power. But I can write it down right now. This is scientific notation. 6.9 times 10 to the 10th power. That's scientific notation. I was supposed to write it down previously, but I had forgot. That was my bad. We got this answer from the problem that we did when we implemented the first method of the power rule. The one where 8 to the fourth raised to the third power, and then applied the first method in which we had to multiply the power and the exponent 4 times 3. And then our new answer was 8 to the 12th power. So after using the calculator to evaluate the rest of that problem, 8 to the 12th power, my calculator gave me the answer 6.9 times 10 to the 10th power. I rounded that off. That's what I did. I rounded that off. So if I didn't round that answer off and my calculator didn't display it in scientific notation, we would have gotten the answer 68,719,476,736. So 68,719,476,736. But that's a long answer. That that's too long of an answer to, which is why my calculator presented it in scientific notation. So what is scientific notation? We're just minimizing writing a long numerical answer. We're just minimizing it. And by the way, we can also convert long decimal answers into scientific notation. But let's start off with this one right here, with the regular long answer. Let's start off with 68,719,476,736. Now, I'm not going to talk about the method. I'll just show it to you. Okay. So we got 68 billion. We're going to basically what we're going to do, we're going to put this in scientific notation. We're going to put this in this notation right here. Okay. And how do we do that? Well, we do it like this. I'm going to rewrite the problem. 68, 719, 719,476,736. This is all we have to do. We start from the end and work our way from right to left, which is heading in a positive direction. We're going in a positive direction when we're dealing with scientific notation. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You go right there. You do not go past you do not go past that last or first number. You do not go past that. So that's how you get the 6.8 and times 10. And how many places did we move? We moved 10 places to the left. That's how we got the 10 right there. 6.8 times 10 to the 10th power. Okay. I'm gonna do it. Let's do another problem. I'm just gonna make up a problem. Let's say 756,123. So I want to put this in scientific notation. Well, let's do that then. Start from the one end and work yourself to the next end, but don't go past the first number. So we got 1, 2, 3, 4, 5. Remember that 5. So if we put this in scientific notation, it would be 7.5 times 10 to the fifth power, because we move 5 times to the left, from right to left. Let's do another one. I'm just making up problems. So let's say we got 1,356,123. Let's go. 1, 2, 3, 4, 5, 6. See that? See that? 1.3 times 10 to the sixth power. Let's do another one. Let's put it, I'll put it right here so it don't confuse you. Put it right up underneath here. Let's do another one. So we got, let's see, 9, 2, 8, 4, 3, 8, 7, 1, 2, 3, 4, 5, 8, 2, 7, 1. That's a whole bunch of numbers there, ain't it? But check this out though. Ain't no problem. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 9.2 times 10 to the 15th power. Decimal notation. Let's create some decimals. Let's create some decimals. We're going to put some decimals in scientific notation. Watch this. With decimals, you go the other way though. Starting from the decimal, you go the other way. So we got 0.000000512. Check this out. 1, 2, 3, 4, 5, 6, 7. You stop right there. That first number you run into. So you get 5.1 times 10 to the negative. We're going in a different direction. Negative 7th power. We're going in a different direction. 5.1 times 10 to the negative 7th power. You see here? 1, 2, 3, 4, 5, 6, 7. Yeah, 5 point. Let's do one more. I can fit another one on here. Let's draw a line. That way you can see it. Different color. Let's do 0.1345678 9. Right? So let's go here. 1. Right there. That's it. That's it. That's it. So you got 1.3 times 10 to the negative 1 power. And there you have it. There you have it, folks. It is what it is.